Welcome back. This lesson is the lesson where we finally get to put everything together. All the stuff we've been doing so far in this chapter is going to come together for this lesson. So, putting it all together. Well, first, let's look. So, our index is going to be 2. So, any numbers that we're focusing on are going to come from that second column. Well, the neat thing is 169 actually is in that column. So that 169 right there actually becomes 13. So in this case, we're lucky. The number pulls out just fine. Let's take a look. How many times does 2 go into 4? So remember, whenever there's an exponent, you're still looking at how many times can that index go into the exponent. So 2 goes into 4 actually perfectly twice. 2 times 2 is 4. So that pulls out as an x squared. And for the y, well, for the y, 2 goes into 6 3 times. So that's going to pull out as a y to the 3. And that's actually it for that one. So let's keep moving right away. This time we're talking about a cube root. So that means we're going to be looking at our third power. And I see 64. Well, in the third power list, 64 becomes 4. Now, the thing I'm noticing here, though, is it's not just a 64. It is actually a negative 64. So because I was actually able to find that number, the 64 does become a 4. But because it was a negative, that actually comes out as a negative 4. So remember, it's always really nice when we can actually find the number in the table. Now, when we're dealing with the exponents, remember, that means we need to see how many times can 3 go into 6. Well, 3 goes into 6 twice, so that means that's going to become an x squared, because 3 times 2 gives us the 6. All right, so let's move right along. Let's go to our next problem. Well, this next one, again, consider a secret 2 being there, so we're talking about a square root. So we're going back to our second column here. All right, now, notice here's that situation where 200 is not actually on our list, okay? So because 200 isn't on our list, we have to look to see what divides the 200. Well, on that list, I see 100, okay? 100 divides 200. So I'm going to split that up. Just go rid of 100 and the square root of 2. Okay? So remember, if the number isn't actually in the table, you go to the next best thing and you find a number that divides it. Now, that square root of 100. From the table, we know that that is 10. Then that 2 is going to be left behind. So I'm going to start with my number, splitting that up. And don't forget to leave some space for the other things you're going to inevitably end up pulling out. Well, let's see what happens with the rest of it. Now that I've taken care of the number portion, now I can take care of the exponent portion. So how many times does 2 go into 10? Well, 2 goes into 10 5 times evenly. So that pulls out as an x to the 5, and there's nothing left over that's left in the radical. Now, how many times can 2 go into 3? Well, 2 goes into 3 once, so I can pull out a y to the first power, but that only gets me up to 2. 2 times 1 is 2, so I still have 1 left over that I need to get up to 3. So that 1 left over has to stay inside the radical. So don't forget that remainder or that leftover piece is always left behind inside the radical. All right, let's keep going. So on our next one, we're back to dealing with a cube root. So let's go back and scan our cube root list, our third power. And we're looking at a 24 this time. Well, again, notice 24 is not actually on my list. So because 24 isn't actually on my list, I need to look for the next best thing. I need to look for a number that divides 24. Well, I see 8. So what I'm going to do, I'm going to split that up into the cube root of 8 and the cube root of 3. I split that up because those are the two things that multiply to 24, and I got that 8 off of my power chart. Well, if you notice, what happens to that 8? Well, that 8 becomes 2. So that's why I pulled that 8 out, because that 8 is going to become a 2 outside, and then the 3 is kind of stuck inside. It can't leave. So don't forget, the first thing we do is we focus on the number piece, and now we're going to turn and start focusing on the exponent piece, on the variables. Well, how many times can 3 go into 5? Well, 3 can actually only go into 5 once. So I pull out just an x to the first power. Well, 3 times 1, so we're still sitting at 3. So that means I have 2 more that I need to get up to 5. So because I still need 2 more, that's going to be a leftover of x squared inside my radical. So remember, whatever it takes to finally get up to the number, those leftovers stay inside the radical. Now for the y. Well, how many times can 3 go into 6? Well, 3 actually goes into 6 twice. So because that comes out perfectly, for that one there actually isn't any piece left behind inside the radical. It just gets to stay nice, just like that. All right, so this one gets a little bit more complicated, a little bit longer. However, as long as you can piece together everything we've been doing, it should be completely doable. So, thank you so much for joining me. Make sure you have all this written down and come and see me if you still have any questions.